everyone, welcome back to AWS Well Architected on Twitch. We're going to share a lot of best practices and tools and a lot of code, of course, on how to build well architected applications. And if you are new to the series, we are covering every pillar and every best practice. Today we're going to talk about reliability. And if you are new to the framework, I highly recommend you take a look at the videos tab and check out the previous episodes here. What we are doing basically is going through the best practices in the AWS Well Architected white paper. And here is the white paper linked on website. And as you can see, it is divided mostly in these questions such as how are you managing service limits, or how are you planning your network topology? And those are the questions we've been through in the previous episodes. Today we're talking about how does your system adapt to changes in demand. And this is a very important part of the cloud architectures and a huge motivation for a lot of people to go into the cloud, and there are many answers for this. Your system will adapt to changes in demands differently if it is based on EC2 instances or Lambda functions or ECS containers. So in the next episodes, we're starting to dive deeper into this and actually building a sample app and starting doing some initial load testing. And today it's going to be with EC2 instances, and in the next one we are going to be doing other types of infrastructure events. So let's jump right into the implementation and see what kind of app and what kind of infrastructure we are testing today. So I'll go to my code editor, and as we've been talking, a very important part of well-architected applications is being able to do stuff with code instead of just doing manual operations. So all that we do in this series is based on code that you can edit, you can change, you can adapt and use as you wish. So here in this link that I just shared with you guys here on this gist, you will find this app called it's Sitting Ducks. It's here, sample code. Okay, so on this Sitting Ducks app, you will find everything that we need for today. So as we are just starting out, instead of picking a full-blown app, I started to create some examples and putting them into this repo. So all the code again that we're going to work today and in this upcoming episodes in these questions are in this repo. I call them Sitting Ducks because they will be our target practice for shooting some requests. So let's start by creating our infrastructure, and I believe I have it already here in CloudFormation, in the CloudFormation Management Console. And just to prove that we are not doing it pre-built, I will just delete everything and let's start everything from zero. So the first thing I'm going to create is an S3 bucket just to store my application files, my deployment packages, my CloudFormation templates, everything that we need to store somewhere. If we don't have a specific reason not to, we should probably take a look at S3 and store it in S3. So here in this first CloudFormation template, we built this a very similar template of a little while ago in the previous episode, but now it's got a few extra improvements. Let's go through it in a bit. So in the parameters, I have a very interesting parameter called gallery ID. And this is something that I invented. It's the name of my environment. Everybody in the world calls this environment. So why did I call it a gallery? Because Elastic Beanstalk has this concept of environment, and I don't want to mix Beanstalk environments to other words and saying disambiguating this all of the time. So by a gallery, I mean an environment, a collection of resources grouped together for a specific purpose, such as production, dev and test, or homolog, or whatever you guys are building. So, to to separate the stacks, we're going to use this gallery ID. So this could be literally anything. By default, it's dev and test. We're going to call this something else. Then we have resources, and here it's just a very simple AWS S3 bucket, named artifact bucket logically in my CloudFormation template. And we have something special here called an export, and this is going to be used for something called cross-stack references, meaning that this name, the name of my gallery ID, referenced by the parameters, so in this example it will be dev and test, will be exported so that other CloudFormation templates can import this by name. So this is just like an environment variable for CloudFormation, if you think. So just a value that you can set and share in your CloudFormation environment so that other stacks can use this value. So let's create this from scratch. And to make it easy for you guys to create this too, I have some shell scripts here. So let's see what those scripts do, and they are all in a very similar format. So I'm going to add set -e so that any failed command here stops the script, so you don't go ahead with anything wrong. And component ID is artifacts, is the name of my component within my environment, let's say. So this is the bucket part, so the first piece of my architecture. And I'm generating a unique name by getting the today's hour, minute, and second. And I'm composing my gallery ID, that first parameter, by being dev, env, and unique, just so we can generate unique name for environments if we need to create several environments. And this is something we are going to experiment a lot in this series, so it's better get used to it from the start. And then the stack name. My CloudFormation stack name will be my gallery ID followed by my component ID. We're going to see how it looks like in a bit. In this case, it's going to be artifacts, dev env artifacts, or something like this. And here is how I pass the stack name. Here's how one very simple way to pass parameters. I'm saying that this parameter gallery ID that's bound here is going to be set to the value of this variable, and this is my template body. So that's just a way to telling CloudFormation how to create this stack. And take a look, this is the important part. This is the create stack command of the AWS CloudFormation CLI. And then we are going to wait until the stack create is complete. And after the stack create is complete, we are going to describe the stack and fetch from the stack that was created the bucket name and output it as a variable. And this may seem a little overly complex for a simple S3 bucket, but I wanted to show you guys how to best parameters to CloudFormation and how to get output results from CloudFormation. So again, here is what I mean. So I will just execute CFN artifacts, and it will return the stack that was just created. And let's go to the CloudFormation Management Console and see what's going on there. So we can see that dev-env191117 artifacts stack is being created, and very soon we'll have its outputs declared here, so we can see what that export things looks like. And of course, the S3 bucket should be created as well. So we have create complete. Our stack was created successfully. Our artifact's name is here, and let me give you more visibility into this. So in our stack named devenv19 ending in 7 artifacts, I have this bucket name. The actual name of the bucket is this. And here's an important thing about cloud computing. Treat your resources like cattle, not pets. So I don't really care what name this bucket have. I don't need to call it my artifacts or anything special. I just give it a name and go. And in the artifact bucket name, this is just a description, but this is the important part. Export name is this, so that every other stack that would like to use or import this value can reference this name. And you can see that I have a naming standard here. I have the name of the environment and the resource ID. So I can, if I have a different environment, it will have a different export name. So this way I can generate as many environments as I want and make sure that the environment won't conflict, right? The IDs won't clash, so I can create any amount of them as I want, because if you try to create an export with a name that already exists, your stack creation will fail. So make sure you take a note of that. All right, so the next step is to do our VPC. So to create our VPC, we're going to follow the same approach. And in the last episode, we discussed network topologies and things that you can do. And here is the template that we built for that. So here on CFN base AJ VPC, this is the YAML file that we have. So the first thing you'll notice is that I have that gallery ID parameter. So when something is created, I can fetch the same parameters and outputs that I had on the previous stack. And this is a very, very important part of CloudFormation development. Don't create these huge stacks. Create separate stacks with just what you need. And this makes it much easier to test and deploy and manage your CloudFormation templates in general. So here you can see that I have the CIDR block for my VPC, and I have 4 networks, 4 subnets. Why is that? Because 2 of them are private, and they are 2, so we have redundancy, 1 in each AZ. So we have a public and a private subnet per AZ, thus 4 subnets, okay? And then the declaration of our resources, the VPC, the subnet, and again, here you can see that trick that we mentioned in the past episode. I am calling the getAZs function on the region, so I know all the AZs from a region and selecting the first, and then for the other subnet, I'm selecting the second, so we don't end up with subnets in the same AZ, because after all, the goal of this is to have high availability regardless of AZ. So the same thing for the private subnets and the resources attached to your VPC, your gateway, your internet gateway, your public route, and things like this. The routing table, all the resources for your network. And again, the same export trick that we did later to make these resources available to other stacks. So CloudFormation is going to create these resources, and using this export, I am making this VPC ID and the subnet, the ID of the subnet, and everything available to other stacks. So again, I have a very convenient shell script to execute this, and it's the very same idea, except that I'm passing parameters in a different way. So you see the different ways the CloudFormation CLI can receive parameters. And here you have it. Here is, I'm just generating a file called CFN base AJVPC JSON with my JSON parameters, the gallery ID that was generated automatically or fetched from the environment, and the VPC block parameters. So instead of using the default 192 address space, I'm using the 10 address space that I'm passing as parameters, just showing you guys how to do this. And then I'm going to create a stack just like the way we did for the bucket, but passing the parameters here as a file instead of directly passing them into the script. And I will need these variables in subsequent scripts. So I'll just create a variable to remember the gallery ID and remember the bucket name. But that's just it. Now we can fire the CFN base AJVPC. And if we take a look at the CloudFormation console, we can see that's already being created. And if we take a look at the resources, oh, here is too big for the screen, but we will soon be able to see the outputs, everything that this template has created. So actually, we don't need to wait for this to happen for the next step, because the next thing is our Beanstalk app. So if we didn't talk about Beanstalk yet, but it's all referenced here in our gist. So here's the homepage for Elastic Beanstalk. And Beanstalk is an application platform for scaling and deploying web apps. So it already knows Java, PHP, Python, .NET, and I mean, it knows how to do deployments on this platform, how are the packages structured, and even Docker if you want to build your own container images and things like that with single images or multiple containers per instance and things like this. So a very powerful application platform for us to start with. I know that you have several architecture options at AWS. We have instances, functions, containers, and we're going to cover all of that. But for today, as this is the first episode in load testing, let's start with regular EC2 instances in Elastic Beanstalk, because I think that's very familiar to a lot of you guys and very simple to get started. So the first thing to create a Beanstalk app is define an application. And this would be again the same of going through the console and clicking in stuff, but here we are defining it as code in CloudFormation. So this is the YAML file that we're looking for. So here, the same gallery ID that we are using to separate our environment, env name, and here is the proper Beanstalk environment, the name that it's going to have on the on the service, and an instance type that by default is T2 micro here. And we can change it to whatever you want. I just added T2 micro so that it's available in the free tier and you can replicate this without spending too much. Then, this is the environment. Before creating the environment, we need to create the app, and this is actually the CFM Beanstalk Flask template. So let's start with this one. So we need the app name first, and the app name is Sitting Ducks. The minimal size of the auto-scaling groups, that's 2 and 20. So I'm letting the user tell me how many instances does he want. He's, in this case, from 2 to 20 by default, but these are parameters you can set on your template. And then I have a role, instance profile role. This is what my instances are going to be allowed to do. So I'm binding the instance to this Beanstalk roles, so they will have access to Elastic Beanstalk APIs, to tell Elastic API Beanstalk that the instances are alive and well when they come up. And those instance profiles are going to be referenced here. The application name will be my gallery ID underscore app name, just as a combination. The configuration template that I'm going to use, and this is my Beanstalk settings. So every setting that's going to be default for all my environments are here. So let's take a deeper look at this. So my application is a reference to the application that was just created. The solution name is Linux latest version running Python. So this is what my infrastructure will be. And an interesting thing here is that Beanstalk automatically figures out what's the latest AMI for this. And so you don't have to map this to different regions and things that you usually see on some CloudFormation templates. And then the option settings. So this option settings is how you tell Beanstalk every setting that you need. So let's take a look at this in the service documentation so that you know what this is actually doing. So here in general options for general Beanstalk, if you go to the reference of this variable, here's how you tell Beanstalk what you want it to do. So for example, this variable called environment type sets your environment to launch just one single instance for dev and test, for example, or an full-blown environment with load balancer and auto-scaling that react as we want to. So we are going to use load balance environments, and this is why you see it here. Our environment type is load balance. Our system health reporting is going to use enhanced health monitoring. The monitor interval is going to be 1 minute. The launch configuration is going to be bound to that instance profile that was created above. And the minimum size and the maximum size of the auto-scaling group are going to be bound to the parameters I just created. And on the outputs, again, this is exporting the application name and the template name. So let's take a look at the script to run this. And this is very, very, very simple. And just the same as we did for all the others, a small change is we are using the CloudFormation deploy command here instead of the create stack. What deploy does is a bit different from create stack. Deploy is going to create a change set, meaning the set of changes that Beanstalk is going to perform in your behalf, and you even can preview this before you apply, and then it's going to apply this change set. And this supports a few different operations. One that's pretty important is the transforms. So create stack does not support transforms, but deploy can actually transform your original template. And this is not something we're going to use now, but in many other features we're going to talk about this. So we better start using deploy, and the parameter passing changes a bit. So here's how we can override parameters for the gallery ID and app name if we even needed to. But let's see, for all practical purpose, it would be the same as we've been doing so far. So let's just fire CFM Beanstalk Flask. And this should start creating our Flask environment. So going back to the CloudFormation console, here we have our stack is already created, and we can see how this is going. The VPC ID was created, and it is VPC 0970, and it was exported as devenv, and the name of my dev environment VPC ID, and the same for the ID of each subnet. So now it comes the fun part, right? The interesting part where we actually make a reference to those values. As soon as our Beanstalk Flask app is created, we can start actually creating environments. And again, here let's just wait for it a bit. While that goes on, I will show you the template. So this is where things actually start happening in terms of compute. This is where we are bringing up our first compute instance, and just now we're starting to actually compute. Before we did the preparation work. So let's just review what we are doing so far. We are creating an application for load testing, and we're creating it using Elastic Beanstalk, and we created the bucket to store the packages and configuration and anything else we need. We created the virtual private cloud, the network infrastructure to host our app, and we created the Beanstalk application, the logical configuration of our app, security settings, and so on and so forth. So now let's bring up an environment. And the first thing that we need is an application version. And the application version is going to be just a bundle of this whole directory. I'm not making, I could be fancier with this build process, and we are going to work a lot in our build process in future videos. But for now, let's just take this whole directory, zip it up, and submit to Beanstalk. And that's how we're going to work. The EB environment is the actual compute environment that we want, and this is the very, very special import value function. The import value function is the one that will bring up a value from other stack and import into this one. So here you can see that my gallery ID, if it's the same, it's going to match the application name that was exported by this stack, and this way I can have references between one stack and another. How cool is that? And the environment name will be that environment name variable, the configuration template. You can see that everything references the stuff that was created on the other templates by cross-stack references. And the important thing to understand about cross-stack references is that it's just a name reference. It's not binding the life cycle of these components. If you delete the environment, you don't delete the stack or the artifacts bucket or anything that we created. I can delete this new environment and keep the rest of the infrastructure untouched. Or even delete other apps and this won't be affected, right? And you can see that this can be used with other CloudFormation intrinsic functions. For example, here I take the subnet A and the subnet B IDs and join them with a comma and pass it to the subnets property of my Beanstalk environment. So this environment is going to be brought up in these two subnets. And in the end, it's going to have an endpoint URL, like where should I target my requests, and this is it. So let's bring this up. And for that, again, we have a convenient script for you. And this script is a bit different than the other ones because it has 3 steps instead of just one, right? Here I have a package command, a cfn lint command, and a deploy command. So let's go through step by step and understand what each one is doing. The CloudFormation package template is going to transform our template from one thing to another. It's going to get a very selected set of properties, change their value, upload it to an S3 bucket, and that's how our S3 bucket comes into play, and output the template to a new template with the variable reference changed. And what is the goal of this? It's to change this value here, the source bundle property. So this source bundle will be packaged by CloudFormation template by this command. So the packaging command is actually zipping the source bundle, uploading to the mentioned S3 bucket, this S3 bucket right here, and output the template to a new file. So if you see then the name of the output file is just the same file but .out.yaml. So if we take a look at the last one that I created here, take a look at this property, the source bundle property. Instead of having just the dot that we had before, so here it was just a small dot, and now it has been replaced by this S3 bucket and this S3 key. So I know exactly where that is. So this is for packaging. And after packaging our template, I'm going to use the cfn lint tool. And this is a linter. It's a checker to see if my CloudFormation template has any errors. So if I have any error in my CloudFormation template, it will tell me. And this is very, very useful to prevent errors, to prevent problems, and then having to wait for the CloudFormation to create everything and then come back. And one important part of this is this linter is just for syntactic errors, not for other kinds of problems such as name conflict and things that CloudFormation will only learn in runtime. But everything that can be prevented from source analysis is going to be done here. And then it's going to be deployed with the same CloudFormation deploy command that we've been using. So let's try that and create our first environment. This should not take, this should take a bit longer than the other commands because the other ones were creating more logical structures. This one is the one that actually brings up an instance. So we're going to have to wait for this a little bit. And while we wait, if you have any questions at all, feel free to ask questions. Hello, determinist. I'm going to paste it again here, the link that I pasted before. And so if you're just tuning in, this is software engineering session. Welcome. This is AWS Cloud Computing. We're talking about scalability. We are trying to answer this question: how your system adapt to changes in demand. So this is our goal of today. And the first thing is to have your system. So to have something to test, we are building up a sample app and starting it with a very, very simple app on Elastic Beanstalk and CloudFormation, trying to define everything as code. And we're going to start firing requests at it just to see how, if we increase the load, how does the system handles it. And that's what we are interested in learning about. And everything that you see here, all the code is available on GitHub. It's just sample code that I'm sharing directly with you guys, and that's pretty much it. So let's take a look at the Beanstalk console just to check if everything is going as expected. And okay, our application is coming up on Elastic Beanstalk. It's still gray, still being created. We can click and see what it's doing, like it's waiting for the EC2 instances to launch, creating cloud alarms and things like this. So if we go to EC2, we can now see our instances. We have 2 instances coming up, right? And soon enough, we're going to have the CloudFormation templates booted. And this is a very, it can be seen as a very complicated way to create a simple CloudFormation template. And I could have done this in many, many different ways. And this is the way that I work personally. And I've discovered that these small tricks, like keeping the templates small, using cross-stack references with a single identifier, generating unique IDs, and creating new environments for testing stuff. This is all just little tricks that helps me, and I hope can help you guys. And but you can sure do the different stuff. This is just one way of using the set of services, but it's there are some really, really interesting things there, and we're going to cover all of these small tips because the set of these small tips can add up and really help your architecture. One thing end up reinforcing another, and that's our goal. So our environment was created, and let's see if it's green. Not yet, but now it is all green and ready to go. So here we have a Beanstalk app, and it says hello. So hello world is our inevitable example. So let's take a look at the code of the app right now. So we are done with the infrastructure code. So we saw those YAML files. Those are the CloudFormation templates that we are using today, and that we can build, right? That we can declare our infrastructure as code. So you can see that everything we built, the instances, the network, the bucket, everything at all, I never even had to get into the CloudFormation console and create anything. Everything is created and managed exclusively by code. And with this, you can automate things very easily and quickly. Again, a few important parts here. Modularize. You can see that I separated my stacks into small stacks that are easy to work, that are easier to test, right? You can also do this in bundles, but after you're done. And let's take a look at it. So let's suppose that you want to create everything at once. I don't want to go through this step of create one, create the other, create the other, create the other, and keep referencing things like this. There is actually a way you can build everything at once. So take a look at this template, Load Testing 101. It's the same set of resources, but here we have this AWS CloudFormation stack resource. And this is very, very, very important because this allows you for one CloudFormation stack to create another CloudFormation stack. So here you can see that I can create the VPC, the Flask app, the environment, and I can say that the environment depends on the app depends on the VPC depends on parameters and whatnot. So the idea here is a bit different because if I delete this stack, if I create this and then I delete, it will delete all the child stacks. And this is the most important difference between nested stacks and cross-stack references. So this is a very important piece of CloudFormation. So let me repeat this to you guys. When you use AWS CloudFormation Stack, you're using nested stacks and their life cycle is bound. So when you delete the parent stack, all the stacks that are defined here will be gone. When you use import value, you're using cross-stack references. And in this way, the stacks are not bound. They just share names with one another. And depending on the behavior you want, one is more appropriate than another. If you just want to manage individual components, you can use nested stacks, cross-stack references. If you want to delete the app and delete all the components, you can use nested stacks, and you can even use them together. So as you can see here, those are nested stacks, but they do have cross-stack references, no problem. It's just a matter of how you group them together, and that's okay as well. So make sure you take a look at CloudFormation nested stacks and cross-stack references. Oh, okay, the code link is here on the document I just shared, SR 1890. Thanks for this, but here is the direct link to the code. Okay, so let's take a look at the actual code of our application. So the app is here on sdux, that's our package, application.py. And you can see that the /root, this is a Flask app, a Python Flask app. So a very popular web framework for RESTful services. Hope you heard of it, but it could be any app, any language would work the same here. It's not something specific for Python now. I'm just taking this application as an example. And we could do literally anything here. I'm just creating an initial example again, so we have something to shoot against. And the shooting is the important part. What you're shooting against in this case, at least for today, doesn't matter very much. So this is the resource Hello World that we just saw, and I have very peculiar hobby of profiling Fibonacci generators for fun. So I got a few of them implemented here, and we're going to see which one is faster. So what do you think? This is the iterative implementation of Fibonacci. So if you don't know Fibonacci sequences, let's take a look to define them. It's just a sequence where the next element is the sum of the previous. So it would be 0, 1, 1, 2, 3, 5, 8, and things like this. I think you got the idea. Everybody knows Fibonacci by these days, I hope. And here's the iterative definition. We're going to go from 1 to n, and for each one, sum the next and return. And recursive implementation is a bit more straightforward. If the value is greater than 1, we return n minus 1 plus n minus 2, or else return the current value. And this is recursive and a bit shorter, and some say more elegant. And this one is using a Python generator. It's lazily computing this as in each call to next, it's going to run one evaluation of this function and yield a new Fibonacci element. And here is a memoized version that will keep values in memory. I have this memoizes any function, and I have a memoized definition of Fibonacci just a bit below. So here's the memoize of the iterative Fibonacci and passing the same x. So I have different paths to each of those. Yeah, we're getting to the load part, to the load testing part. This is the load paths that I'm going to test, and we need a load generator to generate this load, and we're going to start using JMeter. I made a small poll, and JMeter came up as a frequent favorite. We're going to talk about this other performance generators, load test generators, such as Vegeta or Grinder and others. But for now, let's do JMeter. So I have JMeter installed here at my system. Let's see if jmeter.sh should bring it up. No. Let's do it from the proper folder. All right. So I got JMeter up. Let's start a new test plan, and let's add threads as a thread group. And this telling, I'm sorry for the small interface in JMeter. I'm going to keep zooming this in if needed. And here it's just to say how many threads I want to create. I don't like too much to call it users, but what's it doing and how long it's going to take to ramp up to this user number, and how many times it's going to do this. So let's keep one user forever in 1 second just to start. Then add a simple HTTP request sampler, so we can make an HTTP request, and we're going to make this HTTP request to our Beanstalk infrastructure. So here it is. Let's take the endpoint of our Beanstalk stack. Here it is. And this is the server that we are hitting, and we are hitting on HTTP on port 80. And I want let's start with the Fibonacci iterative. And that's it. And to see the results, I can add a listener, and the listeners are listening for the request results, and I will view the results in tree. And this is possibly the simplest JMeter test case we can create. And again, we are just starting with this in this series, and we're going to get every episode adding complexity and other requirements to this, if you will. So here in our case, we have our requests coming along fine, and the request is coming up. We can add the Fibonacci number in the parameters to request. So if I add a parameter named x with the value of 10, just to force these CPUs a little bit, we can reload the test and see the Fibonacci of 10, that it's 55, and how they're coming along. And so everything works fine. Let's do something more interesting. So I will name this fib iter, and you can see we can organize things here. And I will also add the timer, right? A listener to see the results. So I will add a summary report, so we can see the summarized results of what's going on here. And let's start again the test. And this is what we are wanting to see. So in this case, we're not varying the user, but we can start taking some notion of performance. We have like 100 samples, 100 requests fired at our destination. On average, they're taking like 180, 185 milliseconds to complete. The minimum was 126, the maximum 410. This is the standard deviation, no errors so far, 5 of those per second we can reach, and so on and so forth. So the idea here now is, let's see if we increase the user load, how this changes, right? But before that, let's make some configuration changes here. So I will duplicate this and test the other Fibonacci paths that we have. But on JMeter, we have this very useful concept called HTTP defaults. We can set the config element HTTP config the defaults. Let's see, where is HTTP request defaults? Here it is. And I will set this as default for this thread group, so we don't need to repeat this every time. So instead of adding this to each and every one of the paths that I have, I will have everybody shooting at the same port number, the same host, the same protocol, and so on and so forth. And even I want them with the same X, so I'll add the same X. But let's try more interesting value and force the CPUs a little bit more. So I can remove this and shoot. And we can see in the results, clean everything, see if it's coming along fine. So we have the Fibonacci of 20 coming out, and the reports, right? Everything still works. So let's add the other guy. So I will duplicate this to the Fibonacci. Instead of the iterative version, we have a recursive one. So this is fibrec. And duplicate again. We have a memoized version, a generator version first. And this is very simple Fibonacci generators, but you can see this could be any path on your web app. We could have one for login, one for buy, purchase, add user, register, pass different parameters, anything you guys would like. And there is many different approaches to load testing. I don't like recording users so much. Because this is creates it's harder to interpret the results. I think the creating request by hand leads to better results. But again, this is something that everybody does a bit differently. So, and in the end, the memoized version of the algorithm. Just a bit. I will review the server side. Let's just get this working, and we'll go through a review. So here is our load generator, and let's start firing requests, and we can see the requests coming along. And here is just one guy. Remember that our thread group is set to 1, so we're not imposing a lot of load here. We're just playing it nice for a warm-up, and we have very similar numbers here for the average, for the minimum, for the maximum, except for the memoized version that took a while here, but not a lot of differences. So let's stop this and try to impose a bit more on this. So let's start by doing a bit more intensive calculations on the CPU, trying to get the Fibonacci of 30 or something like this. And instead of just keeping with one user, we're going to start, let's say, 10 users and ramp up in 60 seconds. You can see that this will change things a bit. So on the summary report here, you can see here on the top right side of the screen the amount of threads, the amount of users that were created. And yes, it does. This network delay thing is important. If you'd like to reduce the network delays here, and that's a very important part of it, you can run JMeter from AWS. And here I'm running it from a desktop. You could run it on your own EC2 instance or on workspaces. And I have just that running here. And thanks to Terminus, this is a great tip. If you check out Amazon Workspaces, that's a virtual desktop. I have one of those here, and it's just a separate desktop on the cloud where I have the same thing running for my tests. So I have another JMeter instance running here with a lot of requests coming along, and this is running for a long time now. It's generating some errors and things like this. So but as this one is on AWS, it's got shorter network times. So if your network, here I'm at an AWS office, so the network latency to AWS is probably not going to be a problem. But if you need to make sure that network latency is not impacting your tests, I highly recommend running the test from a workspaces or an EC2 instance. So taking a look at our tests, we can see some interesting things now. We can see that here let me enable the zoom here just real quick. I believe it's in mouse, or I need to accessibility, right? I want to show you guys some important parts of this. So this should work. So here we can see that as expected, the recursive implementation of Fibonacci in average takes 3 seconds. And even if we have no errors now, you can see that the minimum and the max and the average for the recursive implementation is very, very different than the other implementations. So here's, again, in a regular app, this would probably be the different transactions and services that you offer. And here's one thing that we can take a look at. And we can see that as we change parameters and change load, these values will impact. And there are two things here that we are wanting to see. When it's the well-looked question is, how do your application behave when your system receives load, when it changes? But what do you want to know? Well, you want to know the numbers, the latency, and the errors mostly. And we're going to talk about percentiles and things like this. And in other reports, and there is a lot we can do here, but for today we're going to be looking at these averages and these errors and make sure that they stay around this. So we don't want many errors, and we don't want to see this change a lot as the application scales up, right? And let's take a look at how we can make it more interesting. So in our thread group, instead of just 10 users, let's go and do 20 users, or better yet, 30 users. And instead of ramping in 1 minute, let's go a bit more gradually and take it in 2 minutes. So when I play this, you should see users ramp up to 30, and in a while it's starting as we expect with very little problems, but soon as things scale, we are going to see some things change. And why and how we define what changes, how do my application react to this? How can we monitor and change what goes on here? And as you know, this is by CloudWatch. As you probably know, this is JMeter totally can be used for testing anything. It's just a matter of setting pointing it to localhost. If you put it localhost instead of AWS, it will shoot localhost. Yeah. So let's take a look at the scaling part of things. How does Beanstalk add or remove instances? This is all done by CloudWatch. So we have a service called CloudWatch, and CloudWatch is going to trigger alarms. And let's take a look at CloudWatch monitoring here and metrics and see what's going on. So here is one example alarm. So this alarm is based on network throughput, but there are many different alarms. We're going to talk about them a lot. And the idea is, when a given metric, here is network out, when the average over a period of time, it could be other statistics, some minimum and things like this, but when a given statistic over a period of value passes a given threshold, in this case 2 million bytes, and it will breach the alarm. And the interesting thing for today is how we define these alarms as code. And this is what I'd like to show you next, because I have here this EB extensions directory, and this EB extensions is where you tell Elastic Beanstalk further properties, further configurations, further templates, anything you'd like to customize and make your application, install packages, run commands, everything you can declare in this .config files under .eb extensions. And this includes CloudFormation resources. So I'm adding more CloudFormation resources from within my Beanstalk app. And a good thing is that this Beanstalk app, this Beanstalk CloudFormation, this CloudFormation from within Beanstalk can make these references. So this is a hard-coded name, let's say, that Beanstalk uses if you want to reference its auto-scaling group, so its auto-scaling capacity. So I created an auto-scaling policy here bound to the Elastic Beanstalk auto-scaling group, saying that this will add one instance when the alarm fires. But the alarm is that actually references the property, so the metric and the policy, right? So here is what my alarm will do. I call it high CPU alarm, and if I have an alarm with for EC2 CPU utilization on this particular auto-scaling group by Beanstalk, when the average for 2 periods of 60 minutes breaches the threshold of 80%, I will fire the alarm action scale up. So this is telling Beanstalk, telling AWS to create an alarm on CloudWatch when the CPU utilization goes over 80% for 2 minutes on average. I will fire this scaling policy, and this will add one. We'll make the adjustment of putting one more instance to our auto-scaling group, and with this, the load will be balanced towards this, and we have a better infrastructure. So Mighty Collins. So the DNS issues are depends on what DNS issues you're talking about, Mighty Collins, and the one thing that ALB does is health check. So the instances will be only put into service once they are health checked, but there's not much you can do about the DNS caches and things that are outside the AWS environment. So it depends on what you do, what issues you mean. Like if you give us a clear definition of the issues that you mean, I can give a further description, but you definitely can use this with ALB, Beanstalk, and CloudFormation do support the application load balancer entirely. So let's take a look at the environment that we just created and see how it's doing. It's on 71% latency. You can see that we reached 50% of CPU utilization and things like this. Let's go a bit more aggressive and do like summary reports. Let's say request harder Fibonacci's to calculate. Let's say 33, for example, and perhaps add a few users like 35 or so. So this 25, let's do 50 just to see it crack. And here on the results, with few users, 3 users, 4 users, we see that the metrics are still fine, but we are going to see that as this progresses and our applications goes on, we need to think a bit more of what to do, because this is clearly I'm going to have to either change my instance type or think better about my fleet and change my architecture to accommodate the load that you plan to use. So, Worldwake, if it's possible to use this kind of testing against machine learning models deployed on SageMaker, yeah, totally. Especially if you put them behind an HTTP endpoint, it makes it very much easy. And it's the same idea. Just fire HTTP requests, and what's behind, if it's SageMaker evaluation or whatever DynamoDB tables, we're going to see this with machine learning databases, serverless, and all sorts of resources. Thanks for asking about machine learning. That's something we definitely should include in the series. And as you can see here, our average times, our like the Fibonacci recursive is taking like 22 seconds already on average, and 5 seconds, 4 seconds, all those averages are increasing a lot. And this is clearly because my as requests are taking longer to process because we increased the Fibonacci number we requested and we have more people asking. Things are starting to queue up. So requests are having to wait before they're calculated in the queue. And if they take long enough, as we'll see, it may even cause some errors. But this is certainly causing our CPU utilization to go higher. So if we open the CPU here, the monitoring period takes a minute, so it will take a while before we see the actual results, but soon enough we will see our metric being breached and our alarm getting caught. So here we have the alarm that we defined, the high CPU alarm that we defined on the environment, and it's just waiting for that 80% threshold to be hit before it fires. So that's how Beanstalk scales. And I mean, I hope we will reach 100%. Is it shooting? I don't know why it's down. It's still shooting. It's 50 users. We will see the CPU getting high soon enough. Okay, and when it breaches the alarm, we'll see the dashboard, the EC2 dashboard. Here we have two instances, right? One running, we can see that they are in different AZs, and this is because the minimum of instances that we have is 2. And if you'd like to see details for individual instances, here we have instance monitoring for each one. And I stopped and started the test, so that's why we are seeing this variance I'm having to wait a little bit for the new ones to come up, but very soon we should have this environment totally swamped by our JMeter requests, right? At least that's what I'm hoping to see here. And when that happens, we are going to see perhaps some errors when we reach 100% or even more. So let's just wait for this monitoring to be updated. So the Beanstalk is even warning here that our environment is with 100 CPU in use. So we are effectively, we still have 100% of 200s, not errors. But if we keep pushing this, we will certainly start getting errors here. And we can see the latency percentiles, 99% of our requests are under 39 seconds, 90% are under this amount, and so on and so forth. So you can see that our environment is totally overloaded, let's say, and soon enough we should have the target. And you can see that those things are not like instant. When it takes a while for the monitoring to pick and react and fire up a new instance. So and that's what we are doing here. So I will leave this running, and soon enough we should see it catching up. Another thing I'd like to show you guys is different approaches to load generation. Right now we are using JMeter, and this is something I'd like to know from you, what you guys prefer that we do in this series. So here's JMeter, and you can see how we start requests and how we define everything in a graphical manner. So here in JMeter, it's a visual tool, a very visual tool, in the sense that if you want to know what it's doing, you have to click and click and click and see the settings and see the tree and see the reports, and everything is very graphical in a sense, right? Of course that you can do JMeter without this. You can run JMeter from the shell and have a report, but it's not the way it's usually used, or the features that it has for reporting this way are a bit limited. But JMeter is a very powerful tool and very complete in a lot of ways. And one thing that I'd like to show that's very unique to JMeter is the tool set that you have. As it's a very popular and traditional Java tool, you have all sorts of plugins. And here in JMeter plugins, it's a very cool website with everything related to other types of tests. So if you want to test Hadoop, SSH, or other types of reports, there's all sorts of plugins that you can install and check. One that's really popular is the JMeter schedule plugin, or I don't remember the exact name. So this is the exact name. Concurrency thread group plugin. Here you can, instead of defining just a thread group and a ramp up period, you can add more steps. You can start with a given load and maintain that for a while, and then ramp up to the next level and maintain that for a while. And depending on the type of desk that you're trying to build, this is very, very useful. So these JMeter plugins may really help. But still, we are talking about taking this graphical orientation and doing things graphically. I'd like to show things. Let me take a look at this question. So Mighty Collins says that by default, Elastic Beanstalk will return IP addresses when clients perform DNS resolution, with the records being randomly ordered. Yeah, the thing is, always use the DNS name, never use the IP. But there is no additional delay from using the ALB. What you have to understand is that when an instance comes up, it will be added to the load balancer and health checked, and only once it's up and running, it will be serving under the load balancer. So it's perfectly safe and works with both load balancers. But back to the load generators, I'd like to show another load generator besides JMeter that takes a different approach, so we can see how the things can be a bit different. And I'd like to show Gatling. Gatling is a very, very popular tool, but instead of defining uh, the tests as an interface and saving them as XML, it's code. So when you save this JMeter file, here is the JMX, here's the XML that JMeter generates. You can't understand, like you're not going to look at this and understand what it's doing, but it's all defined here. In contrast, when you get a Gatling definition, it's code. So here's the Scala code. It's a Scala, but it's a very simplified or a very adapted version of Scala, a domain-specific language, let's say, for HTTP load generation. So here I'm doing the same thing that I did for my JMeter test, and I'll even get the same Beanstalk environment that we are using. So let's fire against it from two tools at the same time and see what happens. And I'm going to use this. And of course, I could be passing this as a parameter or doing this in many different ways. I just wanted to show you that I am defining a value x of 30 and 3 or 4 HTTP test scenarios, the same ones that we had, and I'm ramping up to 120 users. Let's just do 12 over 30 seconds, just to not fire so badly against our environment, and see what it does. So how do we call Gatling? This is the script to call it. Here is where it's installed in my machine, and I just gatling.sf with the at the current directory and the name of the testing class, and that's it. So oops, here it's better. Oh, I don't have Gatling installed on this machine, so let's do this now. I was testing this on a separate one. So this is Gatling. And I just copy it to my home directory, and now it should work. Cannot be found. The class path. It should have worked. So on the current directory, the test is load testing 101 on load testing.1.scala on the package sdugs on user files simulations. Everything looks good. I sincerely don't know what's going on here. Oh yeah, I'm perhaps in the wrong directory. No. Let me try calling gatling.sh directly here. It usually asks for the user file simulations. Yep, sorry about this, guys. I don't know why it's not finding my simulation. This use it to work. Hmm. Well, I'm not debugging this now. I will take a look at why this isn't work, and we take a look at Gatling in the next episode. But again, the more important thing, the information that we would get out of a Gatling report is the exact same. The important part is how you define things. Instead of defining things visually, it's defined in code. No, it's not about the extension because it's the Gatling home is working and Gatling is being called. Hmm. Hmm. Let's see if on the simulation folder is here minus sf is dot. So this is the huh. Yeah, it's probably searching for the directory for the file in a separate folder. So I will give just one attempt, and it may be the case that instead of looking on user file simulations as docs, where it's my project, it may be looking at its own folder, user file simulations here. So I don't know. Let's see. Yeah. I'm not guessing. We'll take a look at this offline and tell you guys in the next episode what it was, and we can take a better look at Gatling. But the idea is the same, right? Get the run this HTTP tests over this period of time with this ramping up to this many users. But the thing is, when you take a look at the Gatling test, or if you take a look at at Locust, it's the same idea. So Locust load testing will be the same thing. Yeah, I didn't even use the see, I just called Gatling. Even without parameters, it doesn't find the. It should have asked for the files. Uh, uh, but Gatling has this some of these issues, and this file loading mechanism is a bit weird. I will definitely have to check it out. So sorry about that. But the important thing is the difference. And you can see the same thing for other languages, such as Python has its own version, and there are many other tools that does similar things. And in this series, we're going to take a look at many of them. We're just starting today with JMeter and should be doing a bit of Gatling, but that will be on the next one. And on on the on the gist, that's what I was looking for. On the gist here, you have the all the load generators that I'm considering here. So just as a quick round, we took a look at JMeter, Gatling, Locust. It's another code-based, but for Python, based on Python. Vegeta will take a file of HTTP request definitions and iterate through them. Very simple tool, but very useful. Bees with machine guns have a property that they do distributed load testing very well. It spin up a cluster of EC2 instances and fire against you. Serverless artillery is this similar idea, but without using servers or machines running on AWS Lambda. And Grinder is an old tool for Java-based load testing as well, that also does distributed testing, but a bit deprecated, not so much actively built anymore. So let's take a look at the most important parts for today. So, and let's see if we have more instances here by any chance. So it's still the same two. I guess we're not putting enough load on this. Let's go and stop this and adding like 35 or even 40 just to completely overload those instances and play. And now it's certainly going to fire that alarm. And I have a few of those running here in a separate environment, and we can also the other thing I'd like to show you guys is how to create everything at once. So again, the YAML that we built and generated everything is running at the same time here in CloudFormation. So let me run it with the So it's going to do exactly the same thing, create the same resources based on the same templates, but it's going to do all in one step and run on the same and bind them on the same stack. So here you see that when you use nested stacks, the stacks that are nested show here as nested, so you can know that they're child of this one. And if I delete this one, it will delete all the child ones. If I update it, it will update all the child ones. So this is the difference between the nested stacks and cross-stack references. So this is pretty much what I had to share with you guys today. And the important things is here is how you define your infrastructure as code, and this is the app that I built for us to start testing, the simple docs here. And we are going to add more resources to this app, serverless resources, databases, containers, just like we did for servers in Beanstalk, we're going to do for all sorts of AWS things. And the way we make the templates is by using this cross-stack references. So make sure you understand this import value and this export value here. So these are the statements that allows you to share values between stacks, and with a very simple naming standard, you can bind things and modularize your development with CloudFormation and any other supported AWS services. And here's the important idea of building your architecture in layers. So we have the S3 bucket for the files, the AJ with the networking infrastructure, on top of it the environments that we want, and the Flask. And this helps a lot because when you're testing your app, you can go to your load to your properties file, to your templates, and make several tests at once. For example, say that I want this environment, but I want two, one with small instances and one with instance type, I don't know, T2 large, for example. So you can so you can see how this impacts on your application performance. And the whole idea here is setting these numbers and testing it on your favorite load generator. Here we are talking JMeter. You could be using Gatling, Locust, and others. We certainly are in this series, and checking how things work. So we can see that things are queuing up a lot. We have errors already, and let's see how the Beanstalk environment is managing. So CPU got up to 100%, but got down suddenly after. I'm apparently not hitting this hard enough, or perhaps too hard. No, not. Yeah, certainly not enough, because I have two instances. This is per instance, but we stopped the test, but we are back to 100%. Very soon we should have our instance coming up. Okay. Let's just wait a bit longer for that. And this is all for today, folks. If you have any question or comments at all, our next episode is this Friday, and we are going to do a very similar test, but without servers. We're going to use serverless functions on AWS Lambda and see how much more or less performant that is compared to EC2 instances. So we are going to fire at the same code at the same time at instances, containers, and functions, big instances, big functions, small instances, small functions and containers. And let's see, start taking some performance understanding and trying to understand the first the performance characteristics, but most importantly the scaling characteristics. You can see that here scaling is totally on me, and I'm responsible for setting the alarms and saying that when this criteria happens, fire up more instances or less instances. And I did it here. So this is the scale up, and I'd like to leave you guys the exercise of doing the scale down. So if you send me the scale down pull request, I would be very happy to add it to our app, and even other scale up criteria that you may have. So scale up by memory or by network or by any other criteria. Any metric that you see on CloudWatch can be used for scaling, and this is how you define it. A very last detail that I'd like to highlight is this policy type on auto scaling, and I added it to our gist. And here in the gist you can see the dynamic scaling for Amazon EC2 auto scaling link, and this will show you that we have these three different scaling policy types. You can either track a scaling, for example, say that you want to keep at maximum 50% CPU and it will scale up and down to this target, or step scaling where you increment or decrease the capacity of your resources to scale up and down, or simple scaling where you have the step scaling actually can be smart about how much resources to add or remove. So if you say 80% CPU add one instance, but 90% CPU add two instances, and 100% CPU add three instances. And simple scaling, it's always the same scaling adjustment. And this is what this scaling type property is, and this is why this is what it's doing here, right? So let's take one final look at things, see how we are doing in our Beanstalk environment. Still not a lot of load. Let me, I will leave it up to you guys. Let's just wait for just one more bit, and if not, we're going to end up here. But I would really like to see this coming up, and it's hard, perhaps sometimes it's hard for network latencies and things like this to push enough load to see the results going on. And if this is the case here, I can always use my EC2 instance and provide a little push to this. So let's do just that. I will get the Beanstalk that I have here and use my workspaces instance to fire more load and make sure that we're going to see these instances coming up. And I will stop this, clean it, set the target. Copy this link. Yeah, I think it's not even responding anymore, right? That's the problem. When it responds, that's one hard thing about load testing. When you start getting errors, and we're probably going to see some errors coming up here. See, it's already erroring, and when it starts to error out, the error response comes very quickly. So your load average come down. So that's why you see this peaks that the average load comes up, but then it starts erroring and it comes down and it comes up again. So it's maybe a bit hard to sustain enough load to actually show it running and scaling. Another thing we could do is reduce the scaling criterion or something like this, but definitely we need to align our scaling so that this doesn't happen. So in the next episodes of this series, what we're going to do is how we create these scaling rules so that this doesn't happen. So you don't see this. So you can scale before you see errors and you see the average going up and your application goes down. You can see that I have totally killed my app. My app is now totally unresponsive. It's not even responding the health checks, and a lot of requests are failing with the request code 500. So to finally answer this, how does your system adapt to changes in demand? We can see that this system in specific is not taking these changes very well, because when we load it up, it doesn't scale fast enough. It shows a bit of error. So in the next episodes of this, we are trying to fix this. I was just trying to show you the most important resources here. So that's how you create Elastic Beanstalk environments in CloudFormation. This is how you use nested stacks and cross-stack references to build your CloudFormation environment. So we are doing a lot of infrastructure as code, and this is how I like to build my CloudFormation templates and shell scripts to trigger them and pass parameters from one to another. And we saw JMeter and the most important JMeter configuration components, the thread group, the for generating users and ramping things up, the request defaults with the configuration for each request, the definition for the request that we want to shoot, and the results tree and summary reports. If you don't like the UI, again, we can use, I have a script here to launch JMeter from the shell, and this would run the same test case, but I don't have the JMeter shell installed here on this machine. Sorry about that. But it's the same idea, the same commands, but generating the output in an HTML form. I'm not going to do this now because the report is not so useful, especially as we don't have the Gatling one to compare. But I can say we take a look at that in the next sessions. So that's it for today. I hope you enjoyed our overview of load testing and infrastructure as code with CloudFormation and Beanstalk. And yeah, and when it's failing, just answering determinism. Yeah, it does respond 500. If we take a look at the Beanstalk environment in monitoring, we can see the on health, actually, you can see that 7% of our requests are 500 requests, or 500 requests. Now it's degraded. Let's hope we can see something here. Because I couldn't, yeah, see, those are for the new environment. But that's the idea. One thing we could do to make it work a bit forcedly is run less users with higher load. So each Fibonacci would occupy one CPU for a long period of time, but then this would be retrofitting the test to the app, and that's not really what we want to do. So we're going to leave the app as is and start working on the infrastructure to make it work and keep healthy regardless of how bad my Python code may be. All right. And that's it for today. We will build upon this, adding serverless resources and more tests and keeping up on Friday. This is an ongoing series. I'm here for about 2 hours every episode. And in each episode, we're going to dive deeper and deeper. You can see that this was a bit deeper than we went on the last session. And certainly in the next one, we're going to see to have a bit more fun with serverless functions and load generators. I hope you like that and see you next time. Thank you so much.